Section 9.5 is alternating series. Now in this section, what we're going to do is we're going to look at series that alternate between positive and negative terms. So an alternating series is a series in the form the sum from n equal 1 to infinity of negative 1 to the n times a sub n, or negative 1 to the n plus 1 times a sub n, given that a sub n is positive or something that doesn't alternate itself. So an alternating series has you alternating between positive and negative terms. To determine if an alternating series converges, we can use this thing called the alternating series test. The alternating series test says, let a sub n be greater than 0. Then, if you have an alternating series like the sum from n equal 1 to infinity of negative 1 to the n times a sub n, or the sum from n equal 1 to infinity of negative 1 to the n plus 1 times a sub n, those series will converge if, first, the limit as n goes to infinity of a sub n is equal to 0, and second, a sub n plus 1 is less than or equal to a sub n for all n. And all that means is that a sub n is a decreasing series. So an alternating series converges if the limit as n goes to infinity of a sub n is equal to 0, and a sub n plus 1 is less than or equal to a sub n for all n. Please note that if the limit as n goes to infinity of a sub n doesn't equal 0, if number 1 is not true, then your series diverges by the nth term test. So an alternating series alternates between positive and negative terms. And we can use this alternating series test to determine if an alternating series converges. Now when we deal with alternating series, what we're going to do is determine, does the alternating series converge absolutely, converge conditionally, or diverge? So let's figure out what absolute convergence means, and then we're going to determine how to find out if our alternating series converges absolutely, converges conditionally, or diverges. Absolute convergence has you taking the absolute value of a sub n. If you can take the absolute value of your series and that series then converges, then the series without the absolute value converges. Again, what we do when we're looking at absolute convergence is just take the absolute value of your a sub n and determine, does that series converge? If the answer is yes, then the series itself converges absolutely. Note, if you take the absolute value of a sub n and that series diverges, and the series that you're looking at is an alternating series, we then go and use that alternating series test that we just talked about to determine if the series converges conditionally. So let's look at example 1, where we determine whether the series converges absolutely or conditionally or diverges. When you're dealing with an alternating series, remember those are the series that are in the form the sum from n equal 1 to infinity of negative 1 to the n times a sub n, or that negative 1 to the n plus 1 times a sub n. When you have an alternating series, to determine if you converge absolutely, converge conditionally, or diverge, the first thing you want to do is find the absolute value of your series. If I look at number 1, I have the sum from n equal 1 to infinity of negative 1 to the n plus 1 over n. Well, this piece right here makes it an alternating series. Why? Because it's going to alternate between negative 1 and positive 1. So the first thing I do is take the absolute value of that. Well, the absolute value of this a sub n is going to be, well, if this is alternating between negative 1 and positive 1, I can take its absolute value and just say 1. Because the absolute value of 1 is 1, and the absolute value of negative 1 is 1. And then the absolute value of n is just going to be n. So the absolute value of this series is 1 over n. Once you determine that, then you figure out, does this series converge or diverge? Well, if I look here, this is a known series. It's a p series. P is equal to 1 here. Therefore, I know that this is going to diverge. Here, part A says, if the absolute value of a sub n converges, well, we didn't converge, we diverged. If you do converge, you're done, you converge absolutely. If the absolute value of a sub n diverges, like ours, then we have to keep going. So because we diverged, we're going to use the alternating series test to determine conditional convergence. Now we're going to try the alternating series test. So to find out if your series converges by the alternating series test, the first thing you have to do is take the limit as n goes to infinity, and it has to equal 0. What's the limit as n goes to infinity of a sub n, which is our 1 over n? Well, that's going to be 1 over infinity. That's 0. Perfect. That's what I needed. The second thing I need to show is that I'm decreasing, that a sub n plus 1 is less than or equal to a sub n for all n. A sub n plus 1 would be, if this is my a sub n, 1 over n plus 1, and I need to figure out, is that less than or equal to a sub n? Well, a sub n is just itself 1 over n. If we cross multiply here, is n less than or equal to n plus 1? Yes, that's true. Therefore, by this alternating series test, our series converges conditionally. If for some reason we would have not had these two conditions met, then our series would diverge. If we look at example 1 again, when we're dealing with alternating series, the first thing we do is we take the absolute value of that series. Then determine if the absolute value of that series converges or diverges. If it converges, then the series itself converges absolutely and we are all done. If it diverges, like in our case, then we use the alternating series test to determine conditional convergence. If we are able to show that the limit as n goes to infinity of a sub n is equal to 0, and that a sub n plus 1 is less than or equal to a sub n for all n, then our series converges conditionally by the alternating series test. If those conditions are not met, then our series diverges.